This is Pre-Calculus Concept 7C, average rate of change. We're going to learn what average rate of change means and how to calculate an average rate of change. And we've got 4 boxes. Box 1, definition. When you hear the word or the term average rate of change between 2 points, usually you're going to be presented with a graph or a table. And all it's really being asked is the slope of the line that contains the 2 points that you're given. So, average rate of change really just means slope. The difference is you're going to be presented the information, usually in a graph or a table. Alright, let's go to box 2. This is an example. This graph here shows the population of California over the past several decades. And the question down below says, what is the average rate of change between 1904 and 1964? So obviously this graph is not a line, doesn't have a single slope, but when it asks for average rate of change, it's going to give you basically 2 points to investigate. So in 1904, if you look carefully, that's a point on the graph, and 1964 is a different point on the graph. And we're basically asking you to think about what the slope of the line that would be that connects those 2 points, and that's our average rate of change. So I'm actually going to copy those down as points. I've got 1904 and the corresponding population 1.79 million, and in 1964 I have the population of it's a little hard to read, but it's 17.29 million. And all we're going to do is figure out the slope between those 2 points. So remember my slope formula. I'm going to plug in my values. I've got 17.29 minus 1.79 divided by, and I'll do the math in my head there, 60 would be the difference between the x2 and the x1. Working that out on my calculator, I get an answer of 0.258. And with these problems, you want to think about the meaning of your answer. So, back up to my graph real quickly. I have a y-axis that represents millions of people, and an x-axis that obviously represents years. And when I figure out a rate of change, I'm actually getting a number that represents millions of people per year. So, what I found out is over the 60-year time span from 1904 to 1964, on average, the population was increasing by about 250,000 people per year. Box 3, another example. This time the information is presented to us in a chart or a table, and what we have here is a car and its value over the first 5 years of its lifespan. So as many of you might know, when you buy a car, it has a certain worth, and as it gets older and older, the worth tends to generally go down, 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 down. Doesn't always go down by the same amount each year, but in this case it's asking us to figure out the average rate of change and over the period in the table, which is a 5-year time span. So once again, we've got 2 points. The initial out the door price is this 16,995 number. So I'll put that as my first point. And my second point, the time would be 5 because that's the length of time later, and the new value there is 5569.17. Okay, once again, I'm just going to do a slope formula, and I'm going to go ahead and go straight to the answer here because I think you guys can figure this out. But we actually get an answer of negative 2,285. So I rounded that a little bit, but that's our answer. Might be a little surprised to get a negative number, but if you think about it, the average rate of change in the value of this car, since the value is actually dropping, it's not surprising that you get a negative number. And in this case, it's dollars per year. So what we figured out is obviously the price is dropping each year, but on average that drop is negative $2,285 per year. Alright, box 4 is a U-try. This is some information about the 100 meter dash world record. And once again, you kind of have information in a table form. The question down below says, what is the average rate of change in the 100 meter world record between the years 1960 and 2009? So I'm going to let you zoom in on the table there. Take a minute and see if you can figure out that answer. Alright, our answer here is taking the information from 1960, which is right here, and our information from 2009, which is right here. I'm thinking about those as points. So I've got our 2 points right there, and then simply average rate of change is the slope formula, and I end up with this final answer of negative 0.008 seconds per 86 seconds per year. What that means is over the course of that time period, the world record was dropping by about that much per year.